Welcome friends to this series of learning containers and Kubernetes. So far we have created many Docker images, we have spun up many Docker containers, and we built the microservices, multi-tier web application, multi-container systems. So far we have done a great job. But all these containers are actually built on a same machine. Now think of a scenario if that particular machine got corrupted or that particular machine got damaged or the entire zone where the machine is hosted made some unfortunate disaster. All the running containers, no matter what are running at that particular system, no matter how much scalability you have done for that particular machine, our application is going to suffer from the disaster and our application will not be available at that moment. Now, here actually the concept of orchestration comes to the picture with the high availability as well. Now, if we can able to spin these containers in many different machines, in different zones or different regions, maybe we can able to address this particular situation if a particular machine goes down. If there is any spike in the network comes into the picture, if our application went viral and our application got popular in a single day, or maybe during the seasonal holiday season where our web application for the e-commerce site got extra traffic. Now, for these extra spikes of traffic, how we can handle that particular extra traffic at the period of the season. We need to scale out our application, and in the span of this scaling, we can think of scaling in different machines in different zone so that the users nearby that particular zone can get the application with low latency. Now let's introduce this Docker Swarm where we can make these things done. There are many other ways to implement this orchestration and scalability. Kubernetes is one of the things, and Docker Swarm is kind of orchestration, and it is having some similarity with Kubernetes, but in a small scale. So we can introduce this Docker Swarm in this particular lecture. So sit back and enjoy this lecture. Now, friends, this is our Google Cloud Web Console. And so far, we have spinned up all the containers and we have run the images with all these things on this particular machine, Docker VM. And it is having an internal IP address 10.128.0.2. And we had only one machine till now. Now we have created another machine, which is Docker VM2, and it is in different zones. So if you can see, this particular VM is actually in US Central 1A zone, but this new VM is going to be served from US Central 1B zone. And it is having a different internal IP address, and both VMs are in a same VPC. So same network, they are sharing the same network. Now, we are going to create the Docker Swarm, and we're going to join Docker VM2 in that Docker Swarm. And we're going to spin up the containers on both of the machines, and we will see if one of the machines goes down, how the other one can solve the application. So let's connect to this particular machine Docker VM and let's see how these can be in action. So friends, this is our Docker VM virtual machine where till now we have spinned up the containers and we had created the Docker images. Now in this particular lecture, we will see how we can use the Docker Swarm to create a service and spin the containers through Docker Swarm. So to begin with that, we can check whether we are having this Docker Swarm or not. So Docker Swarm is a command and through which we can use init and join. Init is for initialize the swarm and join is for joining a swarm as a node or as a manager. Now, let's initiate one Docker swarm and this time we are going to provide the internal IP address of this particular machine and we're going to grab the internal IP of this particular VM 10.128.0.2 and we will say Docker Swarm init advertise address 10.128.0.2 so that within this particular network, this particular IP address will be advertised as the swarm manager. Now, our manager is ready. So this particular node, as it is saying, this is the node ID, and this is saying that it is now a manager. And if any node wants to join to this swarm, then they need to add to this particular network with this token. So let's jump to the another machine and let's join to the swarm. Now we have connected to our second VM, that is Docker VM2, and we can see the swarm is actually there. So let's now let's join to this swarm with this particular token. So let me copy this particular command and let me go to this Docker VM2 and let me paste this command. Now you can see once we have done this thing, it is saying that this second node joined a swarm as a worker. So now this particular Docker VM2 is the worker and Docker VM is basically the manager of this particular node. So if we say Docker node ls, we can see the leader is Docker VM and worker is Docker VM2. Now let's create a service for the Nginx. And this time we're going to use the Docker Swarm for hosting this particular service. So if we say Docker service create and replica 2, and we can give the name of the service as Nginx service, and we are going to use this Nginx latex, which is the Docker image. We can see this as we don't have this Nginx anymore in our system. So it is going to fetch this Nginx from Docker Hub and it is going to run the service. Now, the service is created and we can check the service as Docker service ls. And we can see the two replicas are there. And if we check the Docker PS, we can see this particular Nginx service is running. And if we go to this Docker VM2, we can see another Nginx service is running. And if this particular Nginx Docker container goes down, say, for example, Docker rm minus f, we are going to kill this particular container. And if we check Docker ps, we can see nothing is running. But within a second or so, we can see the another Nginx service got spinned up automatically. Even we can steal this particular container from Docker VM2, and we can able to see within a second or so, there is another container got spinned up. So no matter what happens to this particular machine or this particular Docker container, the Docker swarm will automatically start the container as per the configuration, because we specified replicas, and even we can scale up the replicas if we need so. Say, for example, we need to run 5 replicas at a time, and we can say Docker service update, then the service name and number of replicas. So it is right now starting 5 replicas at the same time within these 2 machines. And we can see our service is right now having 5 replicas. So this is how we can easily scale out and scale in our Docker containers services. And we can even go down to replica from 5 replicas within a matter of seconds. So we can say Docker service update, and then we can specify the replica. And once we do so, we can see that those 3 replicas are going to be scaled in. Now, let's create 4 replicas, and let's see how many Docker containers are running on each of the servers. So we can see each of the servers are running 2 replicas, and it is trying to balance this workload between these 2 servers. Now let's play around a little bit. Let us let's go to this another tab, and let me first set the project ID, and then let me check the current running instances. Gcloud compute instances list. Now, if you are not familiar with Gcloud commands, we have a separate playlist for the Google Cloud compute instances. There you can find different things on GCP Cloud. And we are highly recommending to go through this Gcloud environment and just watch the playlist so that you can be comfortable with Gcloud commands. But here actually we are using this gcloud command only to stop the VM. So gcloud compute instances stop. We are going to stop this Docker VM completely, so that we just want to see that whether if for any reason the entire system got crashed, whether our application can survive with 4 replicas. So right now, the particular VM2 instance is going down, and let us see if we take a second or so, to stop this particular VM. So once we stop this particular VM, this VM will no longer be accessible. And let's see what will happen to this service. All right. So I hope that particular instance is right now terminated or it's actually stopped and we can't able to connect to this VM. Now let us see what happens to this service. So if we check Docker services, we can see still four replicas are running, and we can see these four replicas got created on the leader node. So doesn't matter what happens to this particular VM, we can definitely able to make our application up and running from the other node. So let me start this Docker VM2 once again, and let us connect to this VM, and we will see how this service can be distributed between these two servers. So now our instance is back, and here we can check Docker node ls, and we can see these two Docker nodes are there. And if we check Docker PS, we can definitely see all the containers are running from a single node. And we can check same thing from the other instance. Maybe we can SSH to this Docker VM once again, and we can check Docker PS. Nothing is running as all the nodes are still running from here. But let us let us kill one of the Docker container from here, and we can again check the Docker PS. We can see the three containers are running from here, and the other Docker container which got killed automatically got created from the Walker node. So you can see in this particular video how this Docker swarm is actually spinning the containers across different nodes, and how it can ensure that if the entire system got crashed or it goes down, no matter what it happens with any of the VMs or any of the machines in the Docker Swarm system, the Docker Swarm will actually spin up the containers as per the replica settings we have mentioned, and it will make sure our application is up and running in the system. So thank you for watching this video. I hope that we have enjoyed a lot in this Docker Swarm lecture. See you in the next videos where we will discuss about more interesting features. Thank you.